Hello everybody, this is Dr. Thunder. Today, I would like to show you how to solve a US high school physics competition question. This is question 13 of 2025 F equals MA exam. So, we have a tennis ball launcher. It fires tennis ball along the floor at some initial speed. This is floor. But applying no rotation to the tennis ball. The ball, as we can imagine, initially the ball will slip along the floor, then start rotating without slipping after some moment. So let's ignore the potential deformation of the ball and floor during this process, and we also ignore the air resistance. So we want to find out the behavior of the linear speed v over time, and also the behavior of the angular speed omega over time. We want to find out which is the right answer. I have already shown the answer here, which is answer A, but in a moment I will show you how we get the answer here. So this is a tennis ball with a radius r. So during the ball slipping, there's a friction force between the ball and then the floor, and pointing left. Remember the linear speed of the ball is pointing right. And the friction force is F equal to mg mu. Mu is the friction coefficient. Mg is the gravity of the ball. So now let's apply the impulse momentum theorem here for the force. So the force impulse F delta t equal to the momentum change of the ball, which is delta mv, because mv pointing right direction and F is pointing the opposite direction, so we put a minus here. That means this force will reduce the momentum of the ball. So this becomes minus m delta v. So we get delta v over delta t equals minus f over m. So this is a negative number. We call it equation 1. So this is the first part of the v versus t curve. V just going down linearly with a negative slope based on this relation. Now let's look at the torque impulse versus the angular momentum. So torque is F R, which is the torque. So torque delta t equal to the change of the angular momentum. Angular momentum is I omega. I is the moment of the inertia of this tennis ball. Omega is the angular speed. Because of this friction force, during this slipping, the ball begin to rotate, then get the angular speed, omega. So from this equation, I is a constant, so delta omega over delta t equals to tau over I. We know that tau is Fr, so it's Fr over I. This is a positive number. So from equation 2 here, so in the omega versus t curve, this means for this part, omega going up linearly with a positive slope. Now, as we mentioned in the question, at some moment, the tennis ball will roll without slipping. So at this moment, the linear speed v is equal to angular speed multiplied by r. V equal to omega r. So at this moment, the friction force will become 0. Okay, this is an ideal situation. so friction force will become 0 at this moment. So now if we look at equation 1, because F equal to 0 now, so delta V over delta T is 0, which means this part of the V versus T curve, because delta V over delta T is 0, so that means V become flat versus T, and also delta omega over delta T is also become 0 based on equation 2. So for this part, omega is also become flat with a slope of 0. Here slope is also 0. So that's how we get the answer A here. So thank you for viewing. If you think my video is useful, please comment, like, and subscribe.